Okay, let's just try this question 2 here, and let's just get started here. They said the diagram below shows a triangle, A, B, C, this gray triangle in the middle. The vertices lie on a rectangle. The corners, A, B, C, lie on the rectangle P, B, Q, S, that rectangle there. Now, it turns out, PA and SC are the same. They're T centimeters. We don't know what that is. From P to B, it's 12 centimeters. From B to Q, it's 7 centimeters. They give us that information. Now, the question is, calculate the smallest area possible for this triangle. We want to minimize the area of this triangle. Well, our first job is to find the area of this triangle here. And the big idea is we're going to take this rectangle, which is 7 times 12, 84 square centimeters, and we're going to subtract these little triangles, the one at the top, this one on the right, and this one here. So let's just start. We got to figure out the area of these triangles in terms of this thing we don't know, T. So that's what we do. Now, the area of a triangle is 1/2 the base times the height. Well, 12 could be the base. That's T. So 1/2 the base times the height. That's 1/2 T times 12. Hey, look, we've got the area of the first triangle in terms of T, 6T square centimeters. So 6T is it. Now let's try this angle ACS, this triangle here. Well, 1/2 T, and now here's something a little bit tricky. We know this whole thing's 7, so this part must be 7, take away the T, and that's the tricky part there. It's T, the base is T times the height is 7 minus T times 1/2. And there we get something a little uglier. 1/2 T times 7 is 7/2 T. And 1/2 T times a minus T is minus T squared over 2. It's square centimeters, but we're going to be working with these variables here. Okay, the last one, is the big triangle, BQC. Well, the height's easy, that's 7, but the base is this 12. Take away the T, that gives you the base. And that's why you've got 12 minus T in there for the base. The height is 7 times 1/2. You multiply it out. 7 times 12 divided by 2, it's 42. So there's 42 there. 7 times 1/2, it's 7/2 T there. Well, now we have the area of the 3 triangles. So, and right there, 6T, 7/2 T minus T squared over 2, and 40. We've got that area. So the big idea is we're going to take 12 times 7. We're going to take the whole rectangle, and we're going to subtract those 3 triangles. And it's just going to be a whole lot of algebra. So there they all are. There's the areas. And all we're going to do is take 84 and then subtract those 3 areas. And when you do subtract those 3 areas, you'll get and reduce it all. And it takes a little bit away. You know, you have to go 84. You've got a 42 there. You subtract. That's how I got 42. Do all the algebra kind of carefully and simplify it. And you'll get to 1/2 T squared minus 6T plus 42. Just by putting that 6T, this 7/2 T plus T squared. Anyways, you add all these things and you'll get down to here. Now there's your equation in terms of T. How do we find a maximum? Well, all we do, or a minimum, a maximum, what did they say? Find the smallest area. Hey, that's a happy parabola. We want to find the bottom of that parabola. Then all we do is take the derivative, and make it equal 0. Well, the derivative of this, the derivative is just 2 times 1/2. It's just T minus 6. There's the derivative. Make it equal 0. So T equals 6. That's the value of 6. It will give the minimum area. Well, you've got a formula for the area right here. 1/2 T squared minus 6T. That's a formula for the area of that triangle. Just put that into the formula, 6 into the formula, and you'll get your answer of 24 square centimeters. And that's how you do it. That's all there is to it. Okay.